Hi, here we are discussing about a project, an innovative area efficient pixel shuffling method for image encryption. So here the pixel shuffling is a technique employed in image processing and computer vision to enhance the resolution of image without introducing additional parameters or network complexity. So this method involves rearranging the pixels in a low resolution image to generate a higher resolution output. The pixel shuffling has demonstrated success in various applications including super resolution, image synthesis and style transfer. Here, these traditional methods of pixel shuffling will occupy more logic sizes in VLSI implementations. Thus, the proposed approach of this work introducing image line buffer based pixel shuffling method. This proposed approach done with a 5x5 image line buffer, it will be split and reconstruct the original images. Using this 5x5 image line buffer, this pixel shuffling method handled with a row and column sequence with the help of block interleaver and de-interleaver method. Finally, this work compared with the PSNR and SSIM values and logic size of comparisons will be compared of area, power, delay was analyzed with using a Xilinx software. Okay, so now we can verify the project of architectures and the outputs. Okay, so here you can verify this block diagram. Okay, so here this work initially start with the image to hex conversion with using a MATLAB GUI. Okay, so once we are converted the hexadecimal conversion, then we are given a hexadecimal data as a file reading code. Okay, using the file reading code we are store the data into the memory. After that the data given to the image line buffer 5x5. Okay, so here the first sequence. Okay, so we need to run a MATLAB and this open this GUI. Okay, so first of all we need to load any images. Now I need to load Lena. Okay, so Lena pixel resolution is 130 x 130. So here once we are converted the input image into the hexadecimal conversion, this is a input file. Okay, so here you can analyze the input values. These values we are given into the file reading code. Okay, so this is a test bench of the code, this file reading code, and we are loaded the data into the memory. Okay, so once we are loaded, we are initiate the data to the image pixel shuffling method. Okay, so image shuffling method will wait up to the start signal from the file reading. Okay, so then we will start the image pixel shuffling process. Okay, so first of all we are used a block diagram image line buffer 5x5. so output of this line buffers we are given to the pixel shuffling. Okay, and after that we are given the data to the image line buffer decoder. So this is an image line buffer encoder and this is a decoder, and this is a pixel shuffling block. Okay, so here the pixel shuffling block will come with, okay, so column shuffling, row shuffling encoder and column shuffling encoder, row shuffling decoder and column shuffling decoder. Okay, so here we have a multiple option to choose which type of output we are needed. Okay, so here the mode selections we have choose 00 means row decode, 01 means row encode, and 10 means column encode, and 11 means column decode. Okay, so here the first of all we are choose the column shuffling encode. After that we are done with the row shuffling encode. For this process we have choose some reference paper. So this is one of the reference. Okay, a novel image encryption algorithms using pixel shuffling and pixel intensity reversal. Okay, so using these papers we have analyzed the flow diagrams, okay, and the number of outputs, so how they are encrypted the image with a column and row shuffling based method. Okay, and we are analyzed some more paper, this one, an efficient image encryption algorithm based on a DES touches and hyperchocoustic keys. Okay, so here they are used as a pixel shuffling method, so with a row shuffling and column shuffling, column bit level shuffling. Okay, and this is a real-time signal processing paper. So this also developed with a high resolution image pixel shuffling method. Okay, so as per this concept, we have developed this architecture. Okay, and initially we have loaded the image into the line buffer, right? For that we have used this paper. So this is a line buffer architecture. So here they are used as a 6x6 line buffer, but we have developed with only 5x5 line buffer architecture for 130x130 image resolution. Here for row shuffling and column shuffling method, the row shuffling method done with the block interleaving method. Okay, so row shuffling encoder and decoder. Okay, so for that we have used this paper. Okay, randomized pseudo random interleaving, and as per the same way we are de-interleaving the blocks. Okay, and this output of simulation we have done with the modelism software. Okay, so here use this image Alina, we are run this execution, modelism execution. Okay, so once it will be done, we can analyze the output. Okay, so it's done. Okay, so here you can analyze it. So first of all, up to this, the file reading process into the memory and reading process. Okay, so here the reading process available. So we are generating a read address and we will receive the read data as per the input pixel text file. Okay, so 9389 8B 8B 80A. Okay, here 9389 8B 80A. Okay, so we are reading the data and it will be given into the line buffer. So this line buffer, it's splitting the data into the 5x5 image. Okay, so here the pixel data 1 to 5. So this is the first column and this is the second column, third column, fourth column, fifth column. Okay, after that it will be start the next 5x5 columns. Okay, so this splitting given to the image decoder, and we are decoded it. So in between we are used as a row shuffling encoder and a column shuffling encoder and column shuffling decoder and row shuffling decoder. Okay, so here in the row shuffling encoder you can analyze it. So we are interchanging the bits, okay, and encrypted the bits. Okay, so this is a row data 1 to 5. Okay, and this is a column shuffling method and this is a column shuffling output. Okay, C5 44 43 is C1 44. Okay, and this is a column shuffling decoder blocks. Okay, so after that the finally we will get a original output. Okay, 93 94 90 89 8C. So this data again it will be loaded into the memory. After that we are using a file reading code. We will read the memory and we will put it on a hexadecimal file. So that hexadecimal file available in a output hex. Okay, so it will be present with here. So here output hex it will be loaded. So here you can analyze the same data. So as per that we will get a decoding process output. We can check using output hex file. Okay, here we can analyze the PSNR and SSIM output. Okay, so this is a complete set of encoding and decoding. Okay, here the encrypted image we need to analyze it, right? Okay, so here we can change the mode. So which one we are needed? Okay, so here the encrypted image means, so once completed the column shuffling and row shuffling output. So this one is a encrypted output. Okay, so row ENC. So here row ENC come with 0 1. Okay, so that is a row encode. We are given just 0 1 and you can save it and run the modelism execution. We can analyze the encrypted data. Now we can show only the encrypted output. Okay, so the simulation process completed. So now you can analyze the encrypted image. So this is the encrypted image. We can analyze some other output. Okay, flower. Okay, and we can analyze the same encoded data. Okay, so this is a flower output. Okay, so this is a flower output. Okay, encrypted output. Okay, and we need to change the mode 11 and we can check the decrypted. Okay, so this is a complete image. Here you can analyze the PSNR and SSIM values. Okay, so this work we have synthesized in Xilinx Vertex 5 FPGA. So here you can analyze the number of slice registers, number of LUTs and number of occupied slices, number of IO base. Okay, and synthesis report you can check delay. Okay, 3.847 nanosecond, and you can check the RTL schematic. So this is the RTL schematic for this project. So here input data loaded into the image line buffer. So this image line buffer designed with a number of FIFO architecture. So here we have used 5 different FIFOs. Okay, as per that it will be work. Okay, and this output pixel 1 to pixel 5 given to the pixel shuffling. Okay, so here we have used a column shuffling encoder, output of column shuffling encoder given to the row shuffling encoder, and row shuffling encoder decode given to the column shuffling decode. Okay, so here the column shuffling encoder fully designed with the shuffling architectures of pseudo random interleaving method. Okay, and row shuffling method we have used a block of pseudo random interleaver. Okay, so this is a row shuffling encoders and this is a decoder architecture. This is the overall architecture of this project. Okay, and you can analyze abstract document of this project. So here you can analyze it. Okay, proposed abstract and related notes, disadvantages, advantages. Okay, finally come up with a literature survey and references. Thank you.